vocab. Okay, we're going to talk about something called systems of equations. Okay, a system of equations has two or more equations. Okay, it has two or more equations. So when we say system, like think about it like a friendship, right? You can't have a friendship with just you, right? You want a friendship with somebody else. So, I mean, I guess you can, but typically, if we talk about a relationship or a friendship, it's going to be with somebody else, okay? So, a system of equations is two or more equations.
Thank you.
With the same variables, okay? So, when I say variables, that means our equation, okay, or equations are going to be y equals mx plus b for the most part, okay? We will also see x squared. What do we call those x squared functions? We just got done with that unit. What are those called? Quadratics, okay? We will have both of those. We may see some exponentials, probably not. I don't know if we'll see. Okay, to solve a system, so we're going to talk about solving a system. To solve a system, we find the point where the two graphs intersect. Sometimes they'll intersect never. Sometimes they'll intersect once, and sometimes they'll intersect twice. This is called an ordered pair. So wherever they intersect, they're going to intersect at an ordered pair, x comma y. Like you're looking at a graph, there will be a point where your two lines or two graphs intersect. Okay? What's that?
Our teacher last year had a whole song for this.
Oh, really? Okay, the ordered pair contains x and y values that satisfy both equations. Meaning, if you were to plug in x and y, it would work for both equations. Okay, we will have a case, okay, where we have intersecting lines. Two lines that intersect one time, okay? And there's one ordered pair for that solution. Sometimes we're going to have parallel lines. Tell me what you know about parallel lines.
They don't intersect.
Okay, they never cross, right? They're just like this. So they never intersect. If something never intersects, will that solution, would that system have a solution? No, right? Because the solutions here are those intersecting points. And lastly, sometimes we'll have the same exact line. Like when we look at Desmos, right, and they like sit on top of each other, this is where we have infinitely many solutions because they're constantly touching each other, okay? Their intersection points are constant on that. Does that make sense? So sometimes you'll have none because they'll be like parallel lines. Sometimes you'll have one intersection like a normal, and then sometimes you will have infinitely many, okay? And then sometimes we can have two, and we're going to look at cases like that. Okay. Any questions so far? Beautiful. All right. So it says graph both lines below on your coordinate grid. State the point of intersection for the graphs. So if I look at x equals -2, and I were to graph that, show me what that's going to look like with your arm on the graph. Yes, straight up and down at x equals -2. Okay, so we're going to draw a line at x equals -2. There's my line. Okay, now if I was to graph -3x plus y equals 9, that's a little complicated. We need to get the slope first. So what do I need to do? Add 3x to both sides. So now we have the line y equals 3x plus 9. Okay, so we would plot 9, because that's our y-intercept. And then we would do a slope of 3 over 1. Typically, we would go up 3 and right 1, but that's not really going to work here. So down and left. Oops.
Yeah, remember? I just remember
So you go down and left? Right, I want my line to be going up from left to right. Why do I know that? Why do I want it?
positive. What?
Yeah, it's a positive. Okay, I want it to be going up from left to right. you shouldn't have to draw too many points before you see where those two lines are going to intersect. Do we see the intersection point?
Mm-hmm.
What is it?
-2, 3.
-2, 3. Anybody have issues or questions on that? Okay, I want you to get out a way to access Desmos. Okay, we are going to put in and make sure that we did this properly. Okay, so we will type in x equals -2. Now, when you type these in, the only time you're going to use x equals or y equals is when there's a number after it, and only a number. So if you look at our next equation, actually, I guess this one has the equal to sign because it's not written properly either, but that's okay. We'll just go with it. I'll show you an example when we get there. Okay, if you scroll in, you should be able to click on that intersection point, and it should intersect at -2, 3. Are you check with me okay on that?
Mm-hmm.
Questions?
Is there any way we can do this on our calculator?
We can, but it is a very long process, and since you can use Desmos on your OSC test, we're going to do Desmos. But if you wanted me to show you, I could show you another test. Okay. So, solution for Desmos, it was the exact same, okay, as it should be, making sure that we're doing that right. Okay, number 2, is it ready to be graphed? No, it's not ready to be graphed. So I'm going to rewrite my first equation. How do I rewrite that? What am I going to do first?
Oh, you subtract x.
Subtract x. Okay, what's next?
Divide by 2.
Divide by -2. Okay, so now I have y by itself. I want you to think about what number is going to be in front of x. If we have -1x divided by -2, I'm going to have 1/2. My negatives cancel out because I have negative over negative. So let me ask you, if we were to graph this, what's our y-intercept? Because we don't have a number added. 0, right? If we don't see something, we use 0. Okay, and then your slope is up 1 and right 2.
I can just do that so fast. I'm like 1, 1.
My graph's a little bigger. Drawing the line though, that's where I had my problem. There we go. Okay, my y equals -x plus 6. Is that ready to graph?
Yeah.
You bet. Okay, we don't have to rewrite that. So we have a y-intercept of 6, down 1 and right 1. Okay, you should be able to find that intersection point. Okay, and I'm getting 4, 2. You agree with 4, 2?
Yeah.
Okay, we put it into Desmos to check it.
BFM. I still don't have one.
Okay, you should be able to get 4, 2 for that. Okay, any questions on what we're doing here? Pretty easy? Yes?
Yep.
Okay, let's look at number 3. There's something different about number 3. What can you tell me is different about number 3? It's a parabola, right? X squared is a quadratic. So that graph's going to look like this, or it's going to look like this. Okay? So, in order to get that, because I know we don't have slope and all of that on this one. We can actually put it into Desmos and get a table. Okay, so we're going to go ahead and go to Desmos, and we're going to type in y equals x squared, and I'm going to just add a table for that one. Okay, adding a table there. Or you can just look at these and you can graph these points. Okay, so I will leave that there for you. Go ahead and graph those. Okay, now for your next one, okay, you can go ahead and graph that line. You know how to graph negative 2x plus 3. Okay, you should find on this one 2 intersecting points. Oh, this is a little weird. There we go. Okay, you should have 2 intersecting points, one at negative 3, 9 and one at 1, 1. Now, a lot of people will get tripped up on these because they won't scroll out enough or they won't extend their line long enough when they're drawing it to see both of them. So you have to be really, really careful. Usually when you have a parabola and a line, they're going to cross twice. Okay, that's our case where they're going to cross twice. So you can kind of know when it should happen. That's wrong. Okay, we okay on the parabola and the line? Okay, so on number 4, 5, 6, 7, and 8, you'll see there's not a graph there. What do you think you're going to use to find the intersecting points? Right, because think about it. If we're on the LST test, do we need to draw it? No, we're on a computer, okay? You're going to be able to sort of look at Desmos and see where they cross. So we're going to practice that right now. Okay, so go ahead and on number 4, put in your 2 equations. Both of them are quadratics, okay? So this is something that we have not seen yet, okay? So go ahead and put those in, and then I will show you my graph. Okay, we should be getting something that looks like this. Are you getting the intersection points of negative 3, 4, and negative 1, 0?
Yeah.
Okay, so again, scroll out enough to make sure that you can find all of those intersection points. Don't necessarily trust Desmos to just give it to you visually where it's at. Sometimes you got to move that graph around. Okay, so you should get those points negative 3, 4, and negative 1, 0. Sure.
For the LSD, like, let's say knowing you put 1 and 2 slow.
You would get partial credit. Yep, you would get partial credit for that. Okay, number 5, same thing, we're putting it in. Okay, now, do we have a quadratic and a line? 2 lines, 2 quadratics, what do we have? 2 quadratics, so the same thing should be happening here. Okay, you should see 2 parabolas. Okay, if you're getting the right graph, it should look like the one that's up here.
How are you doing that so fast?
I already put them into Desmos and I just put the picture on here already.
Well,
I just told Desmos to do it like in my mind and
Oh,
put it
yeah.
on my slide.
that's just
Wow.
right there. I think you should become a wizard.
Think so?
Be with Harry.
Harry Potter.
Okay, what? You just like elbowed your desk. Is that what it's gonna go? I'm not saying
Okay, I want you to do the next 3, 6, 7, 8. Do those on your own. Okay, I will put the answers up here. I am going to warn you, 6, 7, and 8, they're not the greatest numbers. Okay, they are not like the ones that we've done. I want to just see what you can kind of gather from what's going on in 6, 7, and 8.
I can't find it. Okay. Let's say don't.
What's that?
Let's say don't.
So, okay, question on number 6. What if they don't touch?
No solution.
No solution.
Well, that's a spoiler alert.
They asked, not me.
Oh, wow.
There's what number 6 should look like. Okay, they do not touch. So they don't necessarily have to be two parallel lines. Sometimes you'll have a quadratic and a line, and those don't touch either. That can happen.
Who I don't like the wizard. These are so weird. Oh. I'm really good.
Okay, I put number 7 up here so you can make sure you're getting the right answers. You can see what that graph should visually look like in number 7.
Those are some weird numbers.
What did I do? Oh, I put the 6, number 6.
Oh, by accident.
Yeah, I'm like,
Okay, that's what I got for number 8. So you can go ahead and check number 8. Once you put that in, make sure that we're on the same page.
Meeting client last week or the week before or something. So we said that series I was supposed to have an issue with. So then
so.
can I get a
Wait, what's on your birthday?
can I get a what's on my birthday?
Happy 11.
Can I get a but I don't know.
All right, group, let's keep moving, okay? Sometimes we won't have equal signs. Sometimes we'll have less than or greater than signs, okay? When that happens, it's still called a system, but now it's a system of inequalities instead of a system of equations, okay? So if we have a solution, everybody say solution.
Solution.
If we have a solution to a system of inequalities, it's actually a shaded region, not a point. Okay, it'll be a shaded region. And I'm going to show you that in just a second. Okay, remember, if you multiply or divide by a negative, you have to flip that sign. Remember when we talked about the sirens?
When you're dividing, don't.
Okay, so don't forget that part. Okay, don't forget to flip that sign. Do these have a solid or dotted line when we draw the graph? Dotted. Okay, so less than greater than is dotted. Less than equal to greater than equal to. Those are our solid lines. Okay, fundamentally what we're doing is the same thing. Now we just have inequalities. Okay, so let's kind of go through here what this looks like. So I'm just going to have you put these in Desmos. Okay, go ahead and just put your two inequalities into Desmos. I'm not going to have you go ahead and graph these, although you should be able to, but it's going to be easier on Desmos.
How will you do it? Just put it in.
Okay, remember you can use on your keyboard greater than, less than.
Oh.
You can also just pull up the, do you guys want to see me put this one in?
Yeah.
Yeah? No? You're good? Okay.
How do you know what the line
It should look like this. Okay? Now, there is an intersection point in this case, but do you see what I mean about a shaded region?
Yeah.
Okay? Here, this shaded region right here overlaps, and it's all of them. So where both of their shaded regions overlap, that is the solution area. So is the point 92 in that solution area? Yes. Okay, the point 92 is definitely in that solution area. What about 0, 0?
No.
No, because it's only in the red area. What about 1, 5? Ooh, that's, okay, so right here.
But no, because it's possible, but it's not definite.
Both of them would have to be solid lines, right? Because this one's dotted, this is not in both. This does not satisfy both equations. Okay? So remember, both of those would have to be solid. Okay, our next one. Okay, we'll go ahead and put number 2, put those into Desmos.
Oh.
Okay, this is what you should see. You seeing the same thing as me? Okay. Now, you want to find the overlapping region, which is right here. This is our solution area. Okay, this guy right here. So, is the point 0, -5 in that solution area?
Yes.
Okay, now, you would have to scroll down, so you should be looking at Desmos. Desmos. Yes, it is in there. What about 5, 5?
No.
5. Yeah, right, that's only in the red. And what about 10, -12?
No.
So 10, yeah, -12 would be all the way down there.
Yeah. Oh,
I can't see it, so let's put it in.
I don't think so.
Guys, we have 4 minutes. Do not pack up. Do not pack up.
There.
Oh yeah. I stress myself. I don't do that.
Oh, because
I'm
we're
sorry.
people.
Yeah.
I'd say yes.
Oh.
Never knew what that meant. When people just go,
Oh, then no.
Okay, guys, back together, please. Back together, please. All right, 10 negative 12. Ooh, never mind. I'm gonna move. That would be here, right? Is it in both? Yeah. Okay. It is in both because here's our red, right? Here's our black. It's overlapping. Okay. This is our overlapping.
It's not negative. Yeah. The two.
Oh, ooh, thanks. Good catch. Zeliquetter?
Yeah.
Oh, okay.
Yeah.
Let's try that again. So 10, no, right? Yeah, now it's not, okay? Because it's like over here. Okay. So that would be no. Okay, we are going to finish these notes tomorrow. Okay, we're going to finish these notes tomorrow. If you can get working on some of the practice, the ones that you can do, go for it. But the rest of the equations we will have to do tomorrow. Okay, our quiz took a little bit of time. So bring this back with you tomorrow.